Compressibility is a property of fluid that tells us how easy it is to compress a given fluid. For example, to understand this, consider three different fluids: fluid 1, fluid 2, fluid 3 in three different cylinders. Now our aim is to compress all these three fluids by unit volume. For example, here there is a cylinder and piston arrangement. Now our task is to move this piston upwards by distance of say 1 centimeter everywhere. Here also 1 centimeter, you have to move this piston by 1 centimeter upwards. Similarly, here also we have to move this piston upwards by 1 centimeter, here also by compressing the inside fluid. And now these three are three different fluids. To move this piston by 1 centimeter in each case, we require three different forces. See this: F1, F2 and F3. It is because though we are moving the piston 1 centimeter in all the three cases, but based on the compressibility of these three fluids, the compressibility is different. The first fluid requires a very little amount of force, F1 only, to move this piston by 1 centimeter, whereas the second fluid requires little more force than the first one. The third one requires highest force than the first and second one. It is all because of the fluid inside having different compressibility. So one fluid gets compressed easily, another fluid will not compress easily. So the amount of force required to compress any given fluid by unit volume is explained by compressibility. For our understanding, among the three fluids, the first fluid having lowest compressibility or highest compressibility, we can say which fluid having highest compressibility and which one having lowest compressibility. So according to our observation, according to our understanding, so we require very little force in the first case. So it is easily compressible. It is having highest compressibility. So whereas if you see the last one, it requires highest force to change unit volume. So it is having lowest compressibility. Compressibility is defined with beta. Beta equals to volumetric change, that is volumetric strain by Tp, change in pressure. So to change unit volume, amount of pressure required. This one explains by compressibility. So beta equals to 1 by K, bulk modulus, K is bulk modulus. K equals to, as we know, K equals to volumetric stress by volumetric strain. What is volumetric stress? For example, consider a cylinder and a piston arrangement and a gas inside, some gas inside. Initially, the volume is inside the cylinder is V1 and pressure is P1. Now I apply some force on that piston so that the piston will move and occupy a new position. Here it is. Then the volume changes to V2 and the pressure increases, that is now P2. So initial conditions are V1, P1, final conditions after displacing the piston, after compressing the gas inside, the final volume is V2, final pressure is P2. Now in this case, how to understand this K, that is bulk modulus? How to understand this K? K equals to volumetric stress by volumetric strain. Volumetric stress here for this gas is change in pressure. The change in pressure is considered as volumetric stress. So initial pressure is P1, final pressure is P2. So there is some change in pressure. That change in pressure acts as a stress on the gas. So volumetric stress is change in pressure, also called dP, volumetric stress by volumetric strain. As we know, volumetric strain is change in volume to original volume. So dV is the change in volume, original volume is V. Let us briefly explain this again. K equals to volumetric stress by volumetric strain. Volumetric stress is change in pressure, that is Final pressure is P2, initial pressure is P1. So dP is P2 minus P1. Final pressure minus initial P2 minus P1 by dV by V. What is this? Volumetric strain. What is dV? So dV is change in volume, that is V2 minus V1. Final volume minus initial volume, V2 minus V1 by original volume is V1. Now if we consider P2 minus P1, among these two pressures, P2 is higher than P1 and V1 is higher than V2. So that's why P2 is higher than P1. This P2 minus P1 gives us plus change, positive change. So P2 is highest value, highest pressure, P1 is lowest pressure. P2 minus P1 gives us plus change, plus dP. Similarly, V2 minus V1 gives us negative change, that is V2 is smaller than V1. So V2 minus V1 is negative change, minus value. So minus change, minus dV by V. So that is why everywhere in bulk modulus formula we will get negative sign. This negative sign signifies what is that negative sign telling us? Very simple. If we increase the pressure, volume decreases. Or if we decrease the volume, say you just move the piston towards right. If you move the piston towards right, volume decreases. If the volume decreases, what happens to pressure? Pressure is increasing. Very simple. If pressure is increases, then volume is decreases. That is why one is positive change, another is negative change. Nothing more than that. Negative sign indicates that if the pressure increases, volume decreases. Only to indicate that one.